All right. Hi. So my name is Luke Hoban. I'm the program manager on the F# group here at Microsoft. And we've seen a few talks about F# already today. My talk's going to be fairly different. It's not going to be a tutorial on F#. It's not going to be an example of some interesting project that I did using F#. It's going to be a set of just sort of interesting observations from our experience taking F# over the last 18 months or so from what it was 18 months ago, a sort of mature research project that had been around for many years. F# about 5 to 6 years old, I think, at this point. So a relatively mature research project that had been done in Microsoft Research in Cambridge. And over the last 18 months, we've transitioned that into something that's going to ship now as part of the next version of Visual Studio in Visual Studio 2010. And so that process has been very interesting. It's involved taking something which had done lots of really interesting, innovative stuff, pulled in ideas from many different languages, and had attracted an interesting user base to the language. And then taking that and bringing it up to the sort of level of quality that's expected when something's in Visual Studio, and sort of the level of functionality that Visual Studio developers and people coming from not looking at just using a language because it's cool, but looking at a language because it can solve all the problems they need to solve and work with all the tools they need it to work with. And so I thought I'd just use this session, I guess, to go through some of the interesting things that we've, coming from the sort of the engineering side of this group, some of the interesting challenges that we've faced, some of the interesting issues that have come up, and talk about those. I think it's particularly interesting with this group because, like we saw yesterday, for instance, a number of examples of people working on languages at various levels of maturity. Some that are, were just started as pet projects, some that have been around for a year or two, and some that are very, very mature. And talking about, like with C#, we're talking about C# v4 features that are very mature. And so this gives one sort of example, one point-in-time example of this particular point in the language's life. But before I get into those, I thought I should at least give a little bit of background on F#. We've seen plenty of sessions today talking about it. But at a core, F# is a functional programming language for .NET. And so what that means is that it's a functional programming language first and foremost. So it is a statically typed, type-inferred functional programming language. It inherits from the ML family of languages, and in particular from the OCaml language. And so the core of the syntax of the language sort of comes from there. But it also is a .NET language. And that means that it has a very rich OO system. It aims to be able to express all the sort of concepts that you can express in a language like C# or VB in its OO system. And it allows those two to be combined in a sort of natural way. So it doesn't just use C# syntax for doing object-oriented programming. It has a syntax that meshes nicely with the functional programming style that you would be used to. And this leads to, the code here is probably not entirely readable. We'll have quite a bit of just sort of graphics and things here. But the general idea is that code becomes quite terse relative to a language like C#, more like what you'd see with a language like Python. But even though it's terse and there's not many type annotations and things, it is strongly typed. So it is strongly statically typed. And so the type information is actually being inferred from the code in a it's very fundamental to the language and the compiler. This type inference is how a lot of the information manifests itself. So that's what the language is from sort of a technical perspective. From a business perspective, and we have to think about that here. We have to convince people it's worth going and investing in these languages. And so from a business perspective, F# aims to sort of extend the .NET platform a bit from where it has its core strengths and towards some areas where .NET has not had the sort of has the penetration that some other tools have had. And so some of the areas where we've seen a lot of interest and we're seeing adoption of F# is in sort of technical computing kind of areas and just algorithmically intensive workloads. Data-intensive workloads where you've got sort of a lot of data and you're trying to work with that and understand it and explore it. And in sort of control-rich environments. So we saw some examples earlier with reactive programming. So places where you want sort of to have a lot of interesting ability to work with your control flow constructs. And then obviously in sort of the algorithmic side, you see things like the example that Jason just showed, where building compilers and that kind of thing, which are highly algorithmic components. These kind of languages, functional languages, tend to be very, very strong at expressing those core concepts. So anyway, that's just a really quick background. So the rest of this talk is just going to be sort of slides with a topic, and I'm going to talk a little bit about how that topic came up and affected our thinking and our planning for the productization effort for F#. And I should say, please interrupt me on any of these to ask about any details I'm leaving out, or to sort of bring up examples that any of you guys have that may have some interesting overlap with these. So the first one is when we started off this effort, as the team in the Visual Studio group was formed, there was actually no F# language specification. So there was a fairly mature language. There was quite a lot of users of that language. There was a lot of tools available to work with the language. But there wasn't yet any specification of what exactly the language was. And because it had been evolving fairly rapidly, it wasn't even totally clear what the language actually was, right? It was whatever the compiler happened to be at that time. And so one of the first things that we obviously had to do was go and sort of start writing down what the language is, getting a spec written. And so one of the things that Don Syme, who's the creator of F# and works in Microsoft Research on F#, one of the first things that he did when we did this productization thing was pull together the spec for the F# language. And obviously, I mean, it probably goes without saying that this is enormously valuable for the development team once that grows from 2 or 3 people to 7 or 8 or 9 people. Having a spec, having some common document where everyone can refer to instead of having to go back to individual sources is just really valuable for our development team. It's also, of course, been really valuable in terms of getting it out publicly, and now it's out there on the web, and so we're getting a lot of feedback on the spec, both in terms of the completeness of the spec and in terms of that helping people to identify bugs in our implementation by going and reading through the spec and finding places where, well, maybe you didn't think through this case. And so we've had a bit of good feedback based on the specification. But an interesting thing that when you go into this productization phase becomes really important. So the other interesting thing, in for a lot of development outside of Microsoft, this the idea that you'd sort of get a user base with a language is obviously that's just what you'd expect over time. With Microsoft technologies, it's interesting when we have research projects. It's not that common for projects from Microsoft Research to migrate over to the product groups inside Microsoft with existing large user bases. Normally, either the project is some very innovative idea that then gets integrated into some existing Microsoft tool, or we go and rewrite enough of it that user base doesn't necessarily transfer directly, that we actually get some sort of shift in the user base of that language. F# is interesting in the sense that it has been around and has had a decent-sized user base as a research language, and so we've actually carried that along into the productization. So we haven't sort of broken the language and said we're going to start again from scratch and just take some of the good ideas. The language has evolved sort of monotonically forward from the research language. And in fact, most of the implementation has remained unchanged. The compiler and things like that we got from Microsoft Research, we've iterated forward. But they were actually fairly high-quality components, even as a research project. And so we were able to take those and just iterate them forward. Now, the interesting implication of this, obviously, is that means we've got a lot of users. And so even though F# in sort of typical Microsoft product group parlance, F# is considered a V1, right? It's been around for 5 years, but it's considered a V1 because it's the first time that we're shipping a sort of product quality version of it. And so it's unique because it has quite a decent-sized user base. We're getting a lot of feedback. We've had public iteration cycles on the language for many, many years. And many of the users of F# have been using it over multiple years and have large teams already working with the language. So we're getting the kind of feedback, not just the feedback that you get from people when they use the technology for the first time, but the kind of feedback that you get from people when they've been using it for many years in a sort of mid-sized team environment. And so that kind of feedback lets us get quite a bit more replies and information back when we're talking about making changes and when we're talking about sort of what areas should we invest in. And this has been very valuable. So this one shifts a bit to slightly more technical kind of side than just the previous two, which were more about kind of the user landscape. So one of F-Sharp's interesting goals, many languages on .NET sort of integrate into .NET, and they expose the ability to consume any .NET types, any .NET methods, to call those. And that already has enormous value because there's a huge library of .NET functionality, and if you can call into all of that, you add a lot of value into your language by having access to those platforms. One of the things that F-Sharp does that is less common is it tries to basically attain the goal of being able to expose any .NET API back to .NET. And so that means that if I have some interface written in C#, I can implement that interface with F#. I can plug into any existing framework, any existing OO hierarchy, using an F# component. And to the extent that we do achieve this goal, and we still don't 100% achieve that goal, but F# is very, very close, actually, to being able to completely represent sort of the OO model of .NET and C#. To the extent that you can achieve this goal, it enables the ability to basically go and say, I want to take this component of my .NET system, and I want to just write that in F#. Maybe there's some productivity benefits for that particular component to be written in F#, so I'm going to go and take that and just do that one little piece. And this allows a very interesting, like at the component boundaries, there's really no distinction necessarily between the languages. And so you can use the languages that fit best. And it really allows .NET to be the mediating thing. Now, of course, this ends up with some interesting implications. So to be able to fully expose everything to .NET, you need a remarkably rich OO model. So .NET and C#'s object-oriented models are quite complex. They have a lot of interesting subtleties to them. They have a lot of concepts they can expose. And it's beyond just the basics of inheritance and things. It's concepts like on the right, I think we have virtual events. So what it means to implement a virtual event is an interesting thing if you ever look at the C# spec. Even simple ideas like in F# I mentioned earlier, we have an OO model, but it's not syntax-wise exactly the same as C#'s. And so in the F# syntax for writing classes, you can write a very lightweight syntax where you just, your type definition defines an implicit constructor. And this works wonderfully. It allows you to write some really simple, really nice OO constructs. But there's a few places where you can't quite express some .NETism. And so for instance, that particular construct isn't able to represent the idea of calling different base class constructors from different constructors on your class, because they all have to go through a single constructor in the F# side. And so in all these cases, we have to find ways to work around this. But it's interesting that as soon as you try to have a different syntax, a different way of expressing those .NET concepts, you end up running into some sort of, you have to struggle a little bit to make sure that that's going to work nicely with being able to expose everything back into .NET. So even though we have this sort of common language runtime and these common concepts in the .NET metadata, if you really want to be able to expose back every single possible .NET concept that C# can expose, it's interesting how much that constrains what your language must look like. So I'm just sort of jumping around to random topics here, but one interesting thing we had, obviously research projects tend to evolve in many different directions, as they're not as constrained by we can only invest in something if it's going to have some direct return in some short time frame. And F# was obviously no exception here. A lot of interesting pieces of functionality were brought into F#, and it had support for many things at an API level that were interesting. And many of these things were also things that the community was actually depending on and using already. And we went into the effort of saying, well, we're going to go and take this and put it in Visual Studio and build one that Microsoft is going to support for years to come. We recognized that not every part of what was in the F# research project was yet at the level where we were ready to make that commitment to it, where we were ready to say, we're not going to want to make substantial breaking changes to some of this functionality, or where we think the quality of the component is now up to those levels. And so what we were able to do is actually take the pieces that aren't yet at that point, and we have this thing called the F# Power Pack, which was alluded to earlier. And so one of the things we're going to do is take some of those pieces of the F# research project that are not going to be part of the Visual Studio release, and we're going to put those into this F# Power Pack, which we're intending to put on CodePlex. And so enable sort of a lot of that functionality to continue to be available for people, and we can iterate it forwards over time. But it's not yet the core pieces of the F# deliverable. It's not yet the core pieces of the functionality. And so we're going to make that split. I think this is just an interesting thing in terms of taking some existing large project and trying to bring it to a consistent level of quality. That we sort of found this way of solving this problem, but it seems like it's one that can come up in a number of places. So sort of this topic is vaguely related to the OO topic I mentioned, but maybe a bit more insidious. So one of the very interesting things you have when you take a new programming language and you want to put it into Visual Studio, Visual Studio supports an amazing variety of tools and services and functionality. I doubt anyone in here could even name half of the stuff that is in Visual Studio, right? Even those of us who work on it full time. It's an enormously large piece of surface area. And so when you take a new language, you've got to decide, well, where are we going to make sure that these tools, these pieces of functionality, where are the important places to make sure that those all work and are available for use with the programming language? And so one of the interesting places where we decided not to have some tools be available was some of the visual designers that are available inside Visual Studio. So we have the ability to do WPF designers and WinForms designers in Visual Studio. And for F#'s V1 release, we won't have the ability to use those to code gen F# code. So you can use those with the C# project, and you can interop between the languages, as we talked about. But the visual designers won't work directly against F# code. And this was an interesting decision point for us. It was sort of two sides to it. I mean, from a user perspective, F#'s, we talked about some of the core business goals for F#. And those users are not necessarily the ones who are going to be, they're not writing line of business applications. So they don't need the drag and drop UI designer as the number one priority of what they're doing. But still, there's a lot of requests and a lot of desire for this kind of thing. So it is something we're going to want to do in the future. So the other reason why we didn't end up doing this is it's really hard. So the less sort of virtuous reason. So it turns out that if anyone here says, how many people here have used the code DOM as sort of an implementation technology in one direction or the other? So a few people have, yeah. So, but basically what the code DOM does is it allows a designer like this one here to produce some tree that represents what kind of code, what kind of meaning it wants to generate. And then the languages can plug in a code DOM provider that turns that tree into some source code. And so this allows a lot of tools inside Visual Studio to do code generation, essentially. Now, it turns out that the code DOM is designed to basically accept any language that is exactly C#, right? Including VB. No, not saying anything bad about VB, but that the languages are very similar, right? I mean, that could be a slight against C# as well, but the languages are very, very similar, right?
Good thing Lisa's in the back.
Yeah. No. So I'm not saying. Okay, I take back any implied offense there. But the languages have a lot of similarity, right? They were both designed to be. They were sort of designed at the same time as .NET was designed, as the CLR was designed. They exposed mostly the concepts that were sort of the first-class things supported in the .NET and in the CLR metadata. As we saw in Jason's talk yesterday, the plan going forward is a continued coevolution. So those languages have a lot of similarity, both in practice and in actual intent. Now, F# certainly has a goal to actually be more different than those two languages are from one another, both from a syntax perspective and from a kind of the semantics and the way that the language feels perspective. And so it's an interesting problem that with the code DOM, essentially, there's two aspects to it. One is that your language has to be able to support everything that C# can support, because the code DOM essentially expects every one of those concepts to be there. And so some designer somewhere may generate some tree which produces one of those concepts. And that one we already talked about. F#, certainly has sort of a Turing equivalence. We can express sort of the same set of things in F# that we could in C#. But it goes stronger than that, because the code DOM allows you to leave off all kinds of information, just sort of randomly. And if you leave off this information, then most of the providers sort of guess what you might mean. And so most of the producers assume that the provider will guess. And they assume that the provider will guess the same thing that the C# provider and the C# and VB providers will guess. And so it means that basically your language has to kind of transition between ideas in exactly the same ways that C# would transition between ideas. And so this is an interesting challenge for F#, because even though, for instance, there's some places where the same C# construct may have two different F# constructs that you might use, depending on sort of some aspect of how you used that C# construct. Now, we have to go and figure out how to infer that. Now, it's easy to explain to a user, here's when you go and pick one or these other techniques. But it's not necessarily easy to look at a tree and say, well, this tree is using it in this way, and therefore it should map to this F# construct. And so there really is this isomorphism concept, I think, is really there. It's not just a one-to-one mapping. It's actually that the transitions between features all have to map in the same way as they would in C#. And so this turns out to be a really a challenging area, and something where, if someone dreams up the right way to do this kind of thing, that will be great. So one more interesting topic. So F# has a language runtime, and so the F# language runtime is called f#.core.dll, and it provides things like the core runtime functionality that is needed to sort of use an F# assembly. So lots of runtime helpers are called into that are in this library. It provides the sort of programming model that an F# developer expects. So the async functionality we saw is in this library. Much of the other functionality that you use, like when you're working with F# lists, you're working with things in this API. Now, for languages early on, when the developer writing in the language is pretty much sitting on the same box as the user using the language, you don't really have to worry about deployment, right? Because you just take the compiler and the libraries and all these things, and we dump them on that desktop, and the developer goes and works with them. Now, one of the things when you get into this sphere of doing component development, which we talked about, F# has this OO system that allows us to build components. We really want to be able to tell users, well, okay, so you can go and just deploy a component written in F# out onto a machine, and you can go ahead and use F# for that component. And so one of the interesting implications of this is we've got to have a deployment story for this runtime assembly. So this has been a really interesting topic that we've looked at a number of alternatives for. And ultimately, there's going to be two ways of doing it, we believe at this point. You'll have an F# redistributable package, which you can, if you've ever used any of these tools you see on the right, like the C++ libraries or the VSTO and things like that, they have redist packages, and you can use those. Or we'll actually, we expect to enable you to deploy this f#.core.dll alongside your application, and then of course it's not serviceable.
Isn't there a third alternative, which is just to employ all of the special F# stuff? Avoid the async, avoid the F# lists, and so on, and just write F# as though it were C#.
Yeah, so the question was, is there another option to essentially avoid any of the F# specific things and use F# as though it was C#? So in principle, yes, we could have designed the language so that you could do that. Now I mentioned there was these two parts to it. There was the runtime helpers and the user-facing libraries. So in practice, there's a bunch of runtime helpers where we need to call in just for using F# at all. You need this, even if you don't use any APIs defined in here. But you could imagine that stuff was cogent into the user's application if needed. But this programming model, because F# has a sort of different programming model in many places, and this sort of where much of its value comes from is it does enable a different programming model. that is something that we need these libraries to enable that programming model. And because of type equivalence and things like that, we can't just stuff all of this stuff into the user's assembly, right? So I think this might be the last one. So one of the other really fun things we've had and really been lucky to have with F# is, Jason mentioned dog fooding yesterday, and there was a question about what dog fooding meant. But yeah, it basically just means we use F#. So on the F# team, almost everything that we own is written in F#. So that includes the compiler and the libraries and the tools. It also includes all the Visual Studio plugins, so the language service and the project system are also written in F#, which gives us very, very different kinds of tools than a compiler. And so, of course, if you see this picture, very subtly, we do actually have a couple of C# projects and even one VB project as part of our solution. So we're sort of true polyglot .NET programmers in some sense, but certainly focused on, yeah.
Isn't that really the same thing? You just said a second ago that C# and VB were the same.
Yeah. Yes, well, it turns out that they're not. So there's some. But actually, I mean, so the reason why we ended up in this situation is one that I think a lot of groups end up in. So the property pages that you have inside Visual Studio, they happen to be written in VB for us, and that's because we inherited a lot of that functionality from C# and VB's property pages, which happen to also be written in VB. And so we pulled that code over, and we're using that kind of code. And so it's sort of as these things go, you naturally inherit some code bases in certain languages. Now, one of the interesting things is that all of this code, as we talked about, these components can sort of easily be in different languages and talk to one another. There's no interop cost in some sense between these languages. They're all talking in terms of .NET OO concepts. And so anyway, so the ultimate really nice thing about this dog fooding is that it means that the entire team is using F# every day, all day. And so we get a ton of just sort of direct feedback. Bugs don't stay in the system very long if they're at all visible. They're found and fixed immediately. And just in terms of feedback on the language and the experience using the tools, we don't need to go all the way to users and back to at least get that first round of feedback about whether things are sort of working, whether they're meeting all the sort of a core set of expectations. We obviously need that feedback loop from a broader set of users to really validate that we're hitting all the scenarios. But at least that first loop we can get pretty quickly, and that's been really nice. So anyway, the end product of this will be F# will be in Visual Studio 2010. So the beta of that, as Jason mentioned yesterday, will be coming out shortly. So this is a fairly old screenshot, but you can see that we have quite a bit of the Visual Studio experience, the debugging experience, the IntelliSense experience, background error reporting. A lot of that tooling experience is available there for F# inside Visual Studio. So fairly rich tooling experience relative to a lot of languages that might be similar to F#. So I think I'm out of time. So some resources in case you do want to go and find out more about F#. There's fsharp.net has sort of the dev center for F#, lots of pointers to other information. There's forums at cs.hubfs.net. And if you're looking for just a tutorial presentation, we didn't have any of those here today. We had quite a few F# presentations, but nothing that sort of went soup to nuts over F#. There's a great talk from PDC last year that Luca Bolognese did. And of course, the best way to learn the language if you're interested is grab one of the books and just read it cover to cover, and you'll know everything about the language. So I'll take a couple of questions. Do I have time for questions? Or okay, yeah, we have time for a few questions if there are any. But there's not. All right. Well, thank you very much.